In this video, we're going to go over all the test 2 questions. Test 2. So the first one, we have 3 different equations that we want to solve for x in. The first one is 3 over 2x minus 1 plus 1 over x plus 1 equals 1 over 2x squared plus x minus 1. So we said before, when we're solving these equations for x and x is in the fraction, we want to get rid of the fraction. And we want to get rid of the fraction by multiplying everything by the common denominator. So to find the common denominator, the first step is, the easiest way to do this is make sure all the denominators are factored. So we can't factor this, we can't factor this. So we want to see, can we factor 2x squared plus x minus 1? Or, yeah, minus 1. And that is, we can factor it actually. So 2x squared plus x minus 1 actually just equals 2x minus 1, x plus 1. So we can factor it into this. So for our common denominator, if you remember from the lecture, what we do is we look at all of our, well, first, actually, let's rewrite everything with all the denominators factored. So the first one, that doesn't change, 2x minus 1. The second one, that doesn't change, x plus 1. This one does change. We're rewriting it as 2x minus 1, x plus 1. So to find our common denominator, what we do is just take all of our denominators and multiply them together, but we only write down each piece once. So what we mean is, well, here's a 2x minus 1, let's write that down. Here's an x plus 1, we haven't written that down yet, let's do that. We already wrote down 2x minus 1, and we already wrote down x plus 1, so we're not going to rewrite those down again. So erase all these circles. So our whole common denominator is just 2x minus 1, x plus 1. So what we're going to do is we're going to take that 2x minus 1, 2x plus 1, and we're going to multiply the whole problem by that. And this is going to get rid of the fractions. So when we multiply it by the first part, oh, I copied something down wrong. This is just an x plus 1, not a 2x plus 1. Okay, everything else looks good. So when we do it by the first part, the 2x minus 1's cancel, so all we're left with is with the 3, and then this x plus 1. So we're going to have 3x plus 1. Then the next part, the x plus 1's cancel, so we're just left with 2x minus 1. From the last part, the whole denominator, oh, we want to write that as the factored version. 2x minus 1, x plus 1. So now all those cancel, the 2x minus 1 and the x plus 1 cancel, so we're just left with the 1, which is in the numerator. So now to solve for this, we got to distribute 3x plus 3 plus, then we have 2x minus 1 is equal to 1. So on the left, we have 5x plus 2 is equal to 1. Subtract the 2 over. 5x is equal to minus 1. And then we get x is equal to minus 1/5. Okay, so there's A. B. So we have the square root of x minus 2 minus 3 is equal to 0. So to solve these ones, we want to get the square root alone on one side and then the number on the other side. So we're going to add the 3 over, which is going to give us square root of x minus 2 is equal to 3. Now we square both sides. That gets rid of the square root. So we have x minus 2 is equal to 9. Add the 2 over, and we're going to get x is equal to 11. For C, we have 2x minus 3 plus 4 times x minus 1 is equal to x plus 10. So to solve this, let's distribute everything. The first piece, that's just 2x minus 3. Then we have plus 4x minus 4, which is equal to x plus 10. On the left-hand side, we have 2x minus 7 is equal to x plus 10. Then we can subtract the x over to the left, and then also add the 7 over to the right. And so we're going to get x is equal to 17. Oh, did I make a mistake? Yeah, sorry, the left hand, this is not a 2x, that's a 6x. We have 4x plus 2x is 6x, and then minus 3 minus 4 is minus 7. So if we subtract the x over from the left, or sorry, from the right, if we subtract this x over, move it to the left, then on the left-hand side, we're going to have a 5x. And then if we add that 7 over to the right, we'll have a 17. Then we divide by the 5, where x is equal to 17 over 5. Okay, so that's problem 1. Problem number 2. Was 2 inequalities to solve for. So the first one we're going to solve for is 3x minus 4 less than 2. So for this, what this actually means is this: we have minus 2 less than 3x minus 4 is less than 2. So that's what it means when we have the absolute. So we can write this off to the side. If we have this less than a, this means minus a is less than x is less than a. So basically, just whatever is inside of our absolute value, we just put in the middle of the two signs like this. So for here, what we want to do is add the 4's over. So we're going to have 2 less than 3x less than 6, and then divide everything by 3. So 2/3 less than x, which is going to be less than 2. And then for part B, we have 5 minus 2x is bigger than or equal to 4. And for over here, what the rule is if we have the absolute value is bigger than a number, this means that x is going to be bigger than a, or x will be less than minus a. So just like before, whatever is inside of our absolute value, we just put it here and we put it here. So what this is going to tell us is we have 5 minus 2x is going to be bigger than or equal to 4, or 5 minus 2x is less than or equal to minus 4. So if on the left-hand side, what we can do is add the 2x over, subtract the 4 over, so we're going to get 1 is bigger than or equal to 2x. And then we can divide by the 2, so we get 1/2 is bigger than or equal to x. On the right-hand side, we have add the 2x over, add the 4 over. 9 is less than or equal to 2x. Divide by the 2, 9/2 is less than or equal to x. So this will be our answer. So number 3, let's just do part B from this one. So what we want to simplify is 2 plus 3i divided by 1 plus I. So remember what this problem is, what we need to do is we need to multiply the top and the bottom by the bottom, but we get to change the sign. So because there's a plus sign there, we're going to make that a minus sign. So what we're going to do is multiply by 1 minus I over 1 minus I. So this is going to equal, we'll have 2 plus 3i, 1 minus I, and 1 plus I, 1 minus I. So if we FOIL out on the top, we're going to have 2 minus 2i plus 3i minus 3i squared. And on the bottom, we'll have 1 minus I plus I minus I squared. And so remember, I squared is equal to minus 1. So let's replace all that. So the top, we'll have 2 plus I minus 3 times minus 1. On the bottom, we'll have 1. Then those i's in the middle cancel. Minus minus 1. So on the top, we have 2 minus a negative 3. So 2 plus 3, which is 5, plus I. And on the bottom, we have 1 minus a minus 1, so 2. Okay, so problem number 4. we want to find the vertex and axis of symmetry. So let's just do part B. So we need to find, well, let's write in the formulas. So our vertex, that's going to be negative b over 2a, f of negative b over 2a. And then the axis of symmetry, this is just going to be the line x is equal to negative b over 2a. And we also want to find the maximum min value. We'll do that after we do this. So for part B, we'll have g of x, this is equal to minus x squared plus 6x plus 3. So negative b over 2a. Well, here's ax squared plus bx plus c. So negative b over 2a equals negative, b is 6, and then 2 times a, so 2 times minus 1. So that's going to be negative, so we have 6 divided by negative 2, which is negative 3. Put a negative in front of that, so it becomes positive 3. So our negative b over 2a is equal to 3. So now let's plug that into g, because we need to find, well, we need to find this, negative b over 2a and f of negative b over 2a. So if we plug 3 in, we get minus 3 squared plus 6 times 3 plus 3, which is going to be minus 9 plus 18 plus 3, which is equal to 12. So our vertex is equal to, so we had negative b over 2a, that was 3. And then f of negative b over 2a, when we plug that in, we got 12. So our vertex is the point 3, 12. Our axis of symmetry, well, that's just going to be x is equal to 3, since negative b over 2a was 3. And now do we have a max or a min? Well, our a value in this problem is equal to minus 1, which is less than 0. And whenever we had an a value of less than 0, this means that we're going to have a maximum. So we're going to have a maximum, and the maximum, so we have a maximum, and the max value is 12. The maximum is always the y coordinate of the vertex. So the axis of symmetry is always the x coordinate, and the maximum is always the y coordinate. Is that all we needed? State whether, okay. So problem number 5. Well, let's do 5a. So what we want to solve is x plus 1, x plus 3, x plus 5 is less than x, or sorry, over x minus 3 is bigger than or equal to 0. So whenever we're solving these fractions that are bigger than or equal to 0, we need to first find our top zeros. And we also need to find our bottom zeros. So the top zeros, just setting the top equal to 0, well, we see that we're going to have then x is going to be minus 1, x is going to be minus 3, x is going to be minus 5. Those are the, so if we set the top of, if we set this equation equal to 0, we see that x is going to be minus 1, minus 3, and then minus 5. So those are our top zeros. And the bottom zeros, that's just going to be x is equal to 3. If we just set this equal to 0, set that part equal to 0, we just get x is equal to 3. Okay, so now we go to a number line and we plug all of these onto the number line. We have minus 5. Not 5, 3. And then we look at our sign. So our sign is a bigger than or equal to sign. Because it has the or equal to part, the top zeros get closed circles. So minus 5, minus 3, and minus 1, they get closed. And the bottom always gets an open no matter what. So 3 was the bottom 0, so we put an open circle on that. Now what we need to do is we need to pick points in each of these sections. So pick minus 10, or we go choose minus 4, choose minus 2, choose 0, and we could choose 7. And what we need to do is we need to plug it into our equation. X plus 1, x plus 3, x plus 5, x minus 3. And we need to see the sign of it, meaning is it going to be positive or negative? So let's start with minus 10. So if we plug minus 10 in, each of these three terms are going to be negative. So we're going to have 3 minus signs. And the term on the bottom will also be minus. So we have 4 minus signs, which gives us a positive sign. So we put a positive sign right here. Our next one, the number we chose, minus 4. The first two terms will be negative on the top. And then the x plus 5 term, that would be positive. And the term on the bottom would be negative. So we'd have 3 negatives and a positive, which gives us an overall negative. Then minus 2. We would have the first term being negative, and then the second two terms being positive. And then the term on the bottom is also going to be negative. So we have 2 negatives and a positive, or sorry, 2 positives, 2 negatives, which gives us a positive. And 0. Each term on the top would be positive. And the term on the bottom, this x minus 3 term, this would be a negative. So overall, 3 positives and negative give us a negative. And then 7, everything on the top is positive, and the term on the bottom is also positive, so we get a positive. Okay, so what are we looking for here? We're looking for this to be bigger than 0. So we want this piece to be bigger than 0. So bigger than 0, that refers to positive sections. So we're going to shade in all of our positive areas. So that's positive. We're going to shade that in. This is positive. We'll shade this in. And over here is positive. We'll shade this in. So that's going to be our answer. So our answer is going to be minus infinity up to minus 5. A bracket on minus 5 because that closed circle. Then we have minus 3 to minus 1. And then 3 to infinity. All right, so problem number 6. We want to sketch f of x is equal to x cubed minus x squared minus 10x minus 8. So the way we do this is, we need to find the zeros of this. However, we're not able to easily factor this. So what we're going to have to use is use division to factor. So if we remember, we have that equation p of x is equal to q of x d of x plus r of x. This part right here, we always refer to as p of x. And so what we're going to want to do is, to use this equation, we need to use synthetic division. And the number we want to use with synthetic division is going to be a number that we plug into here and get 0. But the only way to really find that is we have to do like this guess and check. So we're going to keep plugging in x values into this equation until we can find one that we plug in and we get 0. And the possible ones that we're going to plug in, so the zeros to check, we just choose 0 plus minus 1 plus minus 2. So just easy numbers to plug in and see if we can get one. Just from looking at this, we see 0 is not going to work. If we plug in 0, we get minus 8. So let's see what happens when we plug in 1. So we would get 1 minus 10 minus 8. This doesn't equal 0, so that's not going to work. If we plug in minus 1, we would get minus 1 plus 10 minus 8. Sorry, not minus 1 plus 1, minus 1 minus 1. If we plug minus 1 in here, we get a negative. Plug minus 1 right there, we get minus negative 1 squared, which is minus 1. And so this is going to be 0. So this is good. We found that negative 1 is a 0. So what we do then is we do synthetic division with this minus 1. So we take minus 1, we're going to do synthetic division. So we have 1 minus 10 minus 8. And now we do the synthetic division steps. So pull down the 1, we get 1, minus 1 times 1 is minus 1, add those, we get minus 2. Minus 1 times minus 2 is 2, add those, we get minus 8. Minus 1 times minus a is 8. Add these, we get 0. And if we didn't make a mistake, we need to have a 0 here because we need to have our remainder being 0. So from this, what we see is our d of x. D of x is always going to be x minus this number. So x minus a minus 1, which is going to be x plus 1. For q of x, so notice here we started with an x to the third power. So that means down here we start with an x to the second power. So we're going to have 1x squared minus 2x minus 8. These are just the numbers that appear here. We have a minus 2, and then we have our minus 8. And then our remainder is 0. And our p of x, just to rewrite it, that was the same thing as f of x. So we have x to the 3 minus x squared minus 10x minus 8. So what we actually see is our using this equation. Oh, and I guess we could write this as well too. R of x is 0. So using this equation, we can factor f of x because we need to find the zeros of f of x to graph it. So we can rewrite f of x. We have x to the 3 minus x squared minus 10x minus 8 is going to be d of x times q of x. D of x is x plus 1. And then q of x is x squared minus 2x minus 8. And we can keep factoring this. This is going to be x plus 1. And if we factor this, this is going to be x minus 4, x plus 2. So this piece right here factors into x minus 4, x plus 2. So rewriting everything, really, our f of x can be factored into x plus 1, x minus 4, x plus 2. So now this is what we want to sketch. This is the same thing as this. The problem told us to sketch that. So what we're going to use is this piece right here. And in order to sketch the graph, we need to find the zeros. So if we set this equal to 0, we're going to get x is equal to minus 1, x is equal to 4, x is equal to minus 2. And we want to put those onto a number line. And just like before, what we want to do is we want to plug test points. So choose minus 4, we could choose minus 1.5, 0, 10, and we want to plug it into our equation to see if we get a positive number or a negative number. So if we plug in minus 4, each of those terms will be negative inside f of x. So each of these 3 terms up here, they would be negative. 3 negatives gives us a negative. So minus. We plug in minus 1.5. We'll have the first 2 being negative, the second one being, or the last one being positive. So that gives us overall positive. Then if we plug in 0, we have positive, negative, positive, which is going to give us overall negative. And if we plug in 10, each of those will be positive. So what do we do now? So now we have our graph. We put dots on all of the zeros. We had a 0 at minus 2, had a 0 at minus 1, and we had a 0 at 4. Now to sketch the graph, if we look over at our number line, if we look to the left of minus 2 in this area, well, we see a minus sign. So minus means down, so the graph is going to move down over here. In between minus 2 and 1, we have a positive sign, so it means goes up, then it comes back down and touches the 0. In between minus 1 and 4 is negative. Negative means it go down, but we have to come back up and touch 4. And to the right of 4 is a positive sign, so it just goes up. And so this will be the sketch of the graph. Okay, let's do problem number 8. So we want to find the zeros of the given functions. Number A is f of x is equal to 2x squared plus 3x plus 10. So the first step is always to factor. If we were to try to factor this, we're going to see that we can't actually. So we need to use the quadratic formula. So x equals negative b plus minus the square root b squared minus 4ac all over 2a. So in this problem, our a is 2, b is 3, c is 10. So we just plug that into this formula. So x is equal to negative 3 plus minus the square root of b squared, which is 9, minus 4 times a times c. So a times c is 20, 20 times 4 is 80, and 2 times a over 4. So this is going to be minus 3 plus minus the square root of negative 71 over 4. And then what we can do is we could take that minus sign out and bring an I on the outside. So it's going to be minus 3 plus minus I square root of 71 over 4. So we get two answers. We're going to get x is going to be minus 3 plus I square root of 71 over 4. And we're going to get x is going to be minus 3 minus I square root of 71 all over 4. Okay, and then part B, we have g of x is equal to 2x cubed minus 3x squared minus 2x plus 3. So we want to find the zeros of this. So setting it, we want to set it equal to 0, 2x cubed, 3x squared. So we want to factor this, and before we do what we did in the last problem by doing that synthetic division step, we want to see if group factoring is possible. Like, can we factor something out of these two pieces? In this situation, we see that we can. So from this first two, we can factor out a x squared, and we're left with a 2x minus a 3. From the second two, we can factor out a minus sign, and we're going to be left with 2x minus a 3. So now what we can do is we can factor out this 2x minus 3, 2x minus 3. So both those terms have 2x minus 3s. We can factor that out. And then we are going to be left with an x squared minus a 1. And we can continue factoring. 2x minus 3. X squared minus 1 turns into x plus 1, x minus 1. And then from setting each of these three pieces equal to 0 from this first one, we're going to get x is equal to 3 over 2. From the next one, we're going to get x is equal to minus 1. And from the last one, we're going to get x is equal to positive 1. Okay, and then, oh, was that the last question? Yeah, so that was the last question on this test. Okay, yeah, so I'll make the last video about the, all the same stuff with the third test.